Hey guys, today we are going to be talking about dilations, which is a new type of transformation, and also cross multiplication. This is something that we are going to be using quite a bit in the upcoming topics here, so we're kind of just getting started on learning that skill as well. So before we talk about some examples, I have these like notes here for you, and they lay out what dilations are pretty nicely. I do want to point out some important parts in here. So what a dilation is a transformation that maintains the shape of a figure, but multiplies the lengths by a chosen factor. Okay, so when you're dilating a shape, you're taking that shape and you're making it bigger or smaller by a certain factor, by a certain multiple, but that doesn't change the shape itself. And that factor will remain the same for all the sides of the shape. So it's not like one side of the shape will change by a factor of 2 and then the other side will change by a factor of 3, right? It doesn't work like that. All the sides will change by the same factor so that the proportions stay the same. Okay, so it's, as it says right here, a figure is stretched proportionally from a particular point. That proportion piece is very important with dilations. Now, while dilations do change the size of shapes and oftentimes the location on a graph, it does not rotate the shape, doesn't reflect the shape, and it's also very important to note that dilations do not change the angles of a shape. Okay, side lengths change, but angles do not change. All right, so let's take a look at what this is going to look like in action. We can dilate shapes randomly, just like here with this purple example, or we can do them on a graph, which we'll see in our upcoming example down at the bottom here. So I have a rectangle, it's a 7 by 12 rectangle, and if I wanted to dilate it by a zoom factor of 2, right, that means that my new rectangle is going to have bigger dimensions that are twice the size of these, okay? First of all, we know that since it's a rectangle, the opposite sides are equal, so I'm just going to go ahead and throw a 7 here and a 12 here, just so we're clear. And then, because the zoom factor is 2, I'm going to go ahead and take all of my dimensions. Ooh, I want the skinny pen. Take all my dimensions and multiply them by 2. It's simple as that. Multiply all my dimensions by 2. Okay. So that's going to give me new dimensions. 12 times 2 is 24, so I'm going to have 24 centimeters at the top and bottom. And on the left and right, 7 times 2 is 14. So these two sides are 14. All right, so now we just have a rectangle that's twice the size of this original rectangle, and that is a dilation. All right, so that is just when you do a random dilation, like not on a graph, you're just changing the size of a shape. But here, we also can dilate dilate shapes on a graph, and that is going to look like this. I'm going to give you some steps so that you can follow those, and it might make it a little bit easier. The first thing you want to do when you're dilating figures on a graph is find the coordinate points, okay, or identify the coordinates. And coordinates is just fancy talk, like fancy math language for like the points, you know, the x, comma, y points. You want to find the coordinates of the vertices, okay, those are all like the corners, the pointy parts of your shape. All right, once you have found the coordinates of your vertices, the next thing you're going to do is take those points and you're going to multiply them by the zoom factor that you are given. And it might sound a little confusing while you're watching this right now, but once we do an example, it'll all make sense. All right, so multiply those coordinates by the zoom factor. All right, so now that we are going to multiply the coordinates by the zoom factor, and remember that means that you're going to multiply like the x and y value of a point by that zoom factor, we will have new points, and those new points need to be graphed to create the new shape. So you'll graph them, and then you'll connect your dots. And that will be your dilation. All right, so let's take a look at what that looks like in action here. I'm going to zoom in a little bit so that that tiny shape can get a little bit bigger. Okay, so here we have a little shape on a graph. Let's just go ahead and follow our steps. The first thing we want to do is identify the coordinates of the vertices. So I have 4 vertices here. Let's start with E, and we'll go around clockwise. So E is at a point. Now, when you're figuring out what the point is, you got to remember that your original starting point on graphs is at 0, 0. And then to figure out how to get to my new point, that's thick, we got to see how we moved. So since I moved to the left 1, and remember, let me put a little guide here. The x value is your left and right movement, and the y value is your up and down movement. So I moved to the left 1, which means I'm going to put a -1 because it was left. And then I didn't move up and down at all. I stayed on the ground here, so I'm going to put a 0 for the y value. All right. The next thing I'll do is go ahead and do point F. Let's do that in green. Point F is at a place where it didn't move left or right anywhere, right? We just stayed only up and down from black. So we moved up by 1 box. So since we didn't move left and right, we put a 0 in the x spot, but since we moved up 1, we'll put a 1 in the y spot. All right, next is G. Okay, point G is going to be, let's see where we moved. From black to blue, we moved to the right by 1, so that's going to be 1 from the x value. And we didn't move up or down anywhere, so it's going to be a 0 here. Okay, and lastly, we have H. So H, and for this one, to get from black to purple, we went to the right by 1 and then down by 1. So because the right one is positive and the down one would be negative, we end up with 1, -1. Okay, so left and down are always negative, and then up and right are always positive. All right, now that we have our old points, our original points, we've done step 1. On to step 2, which is to multiply the coordinates by the zoom factor. Now our zoom factor is 3. All right, our zoom factor is 3. So we're going to go ahead and take every point and multiply it by 3. So I'm going to take this one, let's do the same one. I'm going to take each part of each point and multiply it by 3. So this is going to tell me that I get a point of -1 times 3, which is -3, and 0 times 3 is just 0. So this is my new point. Now remember, a dilation is a transformation, so I do expect to see proper prime notation. Okay, so my E prime is at -3, 0. Next we have F. We do the same exact thing. Multiply the coordinates by 3, since 3 is my zoom factor, and find out that F prime is 0 times 3 gives me 0, 1 times 3 gives me 3, so I end up with 0, 3. All right, on to G. Now, g was originally 1, 0. We're going to go ahead and do what we've been doing, which is multiply everything by 3. So g prime is going to be, let's see, 1 times 3 is 3, and 0 times 3 is 0, so 3, 0. All right, my last point, h. Same steps, times 3, and this tells me that 1 times 3 is 3, negative 1 times 3 is negative 3, so that's my fourth point. All right. Now we have completed step 2, which was to find the new points by multiplying everything by our zoom factor. Now, step 3, the final step, is to just graph those and create our new shape. So, e prime is at negative 3, 0, meaning from 0, 0, I'll move to the left by 3, 1, 2, 3, and I won't go up and down at all because there's a 0 in the y value. So e prime is right there. For f, we are at 0, 3. So starting at 0, I don't move left or right because there's a 0 for the x, but I do move up 3. So I'll go 1, 2, 3. This is where f prime lands. All right, on to g. We have 3, 0, so I'm going to start at 0 and go 1, 2, 3, and then I don't move up and down at all, so just put that there. And h. And 3, negative 3, so I'll go right 3 and then down 3 and up here. H prime. So I have made my whole shape, so I'm going to go ahead and put the lines in. I'll connect my dots just like they originally had theirs connected. All right, and that is my newly diluted shape. Notice how it looks exactly like the first one, but it's just bigger, right? Okay, so that's all for dilations. Let's move on to another skill, the cross multiplication. Zoom back out of this a little bit. All right, so like I said, this is a skill that we did learn in algebra. So what you're going to do is get your diagonals. This is one diagonal, 2 times 8. And then your other diagonal is x and 6. So we'll do 6 times x. And then you just set your diagonals equal to each other, okay? And from there, all you have to do is solve. So we know that 2 times 8 is 16. 6x just stays 6x. Okay, at this point you got to get x by itself, so let's divide both sides by 6. And that tells me that my answer is 16 over 6, or 8 over 3 if you simplify. All right, so these are pretty fast. If there's, sometimes they can be longer, but these ones with just one term in each spot are super quick. Let's do another one. We have our first diagonal here, which has an x and a 3, so I'll multiply them together, set them equal, and then the other diagonal has a 2 and a 6, so I'm going to multiply those. Once you get the setup right, it's pretty easy going after that. So we end up with 3x equals 12. So our last step to get x by itself would be to divide both sides by 3. So x equals 4. All right, one final problem. I am running out of time here. I have my 15-minute time limit. So I'm going to try to hurry get through this one. So we have our diagonals. We have one that's 12 times 2x minus 1, and the other is 3 times 10. All right, this is just an algebraic equation. We got to distribute. So 12 times 2x is 24x. 12 times negative 1 is negative 12. This is just 30. All right, so now we just solve for x. Add 12 to both sides. 24x equals 42. And divide both sides by 24. x equals 42 over 24. We can simplify that, but we don't need to.